Hi everyone, and welcome back to AI Tools and Automation for Everyday Use. If you're a developer or automation builder interested in real-world AI agent workflows, this video is for you. In this episode, I'll walk you through the technical challenges I faced while building my AI Quartet singing evaluation agent and how I solved them using tools like Zapier, n8n, Python, GitHub, Deepgram, and Backblaze B2. This isn't just a product demo, it's a look behind the curtain. If you've ever tried to connect multiple platforms together for a serious workflow, you know that success isn't about flashy UIs. It's about resilience, debugging, and workarounds. Let's dive in. My initial plan was to build everything in n8n because I self-host it and it gives me unlimited tasks, which is ideal for scaling without increasing cost. But I ran into two key limitations right away. First, the Google Sheets integration. When I tried to verify a student's email against a registration list in a Google Sheet, for example, checking if the email they used to upload a song actually exists, n8n would return nothing if the value wasn't found. That doesn't sound too bad, but it's a major issue. Because n8n returns no value at all, I couldn't even send an error message to the user. I wanted to send a friendly email like, "Hey, the email you used isn't registered. Please use the one from your sign-up form." But n8n doesn't let you do conditional logic based on a failed lookup in Google Sheets, at least not in a reliable or clean way. Second, file upload limitations. Since I host my own n8n instance, I quickly realized that my server configuration doesn't support large file uploads, especially binary files like MP3s. This was a deal breaker. My entire workflow depends on users uploading audio recordings for evaluation. To get around those two roadblocks, I made the decision to shift part of the system to Zapier, and it immediately solved both issues. First, Zapier handles Google Forms plus Google Drive uploads seamlessly. Students can upload MP3 files using a Google form, and those recordings go directly to my drive. Zapier captures the file's download link and continues the workflow without any server-side upload needed. Second, Zapier's Google Sheets integration is much better at handling missing data. I can easily check whether the submitted email exists in the registration list, and if it doesn't, Zapier lets me send a tailored response to the student via email. Exactly the kind of conditional logic I needed. I didn't abandon n8n entirely. I kept one workflow running there, the one that manages user transactions for my WordPress plus WooCommerce site. In that case, n8n is a better fit because it gives me deeper integration with WooCommerce. And unlike Zapier, I don't need an expensive premium plugin to do things like custom webhook handling, metadata extraction, or dynamic filtering. So now I'm using both platforms, Zapier for its stability and integrations with Google services, and n8n for its flexibility and better handling of e-commerce workflows. The app itself is structured into 7 modules, all accessible from a single landing page on my WordPress site. Each module represents a different function in the system, and each one starts with a Google form. That form feeds a connected Google Sheet, which then triggers a Zapier workflow. For example, professors can submit their MP3 reference recordings and specify the voice part, bass, tenor, lead, or baritone. Those files are saved in Google Drive, and their direct download links are stored in a master spreadsheet. That sheet powers drop-downs for students and also serves as the source of truth for matching recordings later on. The student workflow starts similarly. When a singer uploads their performance using their own Google form, Zapier grabs the student's MP3, matches it to the correct professor reference based on the song and part, and passes both files into the evaluation pipeline. Now let's talk about the AI evaluation. Once the student and professor MP3 URLs are matched, the next step is transcript analysis. Zapier sends both files to Deepgram, an AI-powered speech recognition API that converts the audio into text. At first, I was simply transcribing the student's recording, but I realized that without a reference, I had no way to measure how complete or accurate the student's lyrics were. So now, both recordings, the student's and the professor's, are transcribed. Once I have both transcripts, they are passed to ChatGPT via the OpenAI API. ChatGPT does a comparative analysis, evaluating how closely the student followed the lyrics, whether key emotional lines or narrative moments were skipped, and how well the timing and delivery aligned with the original. This analysis becomes part of the final report. It's written in natural language, so the student gets clear, constructive feedback, not just raw scores or technical data. Next, the real technical challenge, pitch analysis. I needed a way to visually compare the pitch of the student and professor recordings. For this, I built a Python script hosted on GitHub Actions, which downloads both MP3s, uses Librosa, a Python audio analysis library, to extract pitch data, and plots the pitch over time in a side-by-side graph. This graph lets students see where they're singing flat, sharp, or off rhythm, but here's the issue I ran into. Google Drive has strict limits on file sizes when an application, not a user, tries to upload a file. The pitch graph was too big. It would fail silently or time out. After researching various storage options, I landed on a great solution, Backblaze B2, a cloud object storage service that's free for small projects and supports uploading via the AWS S3 API. One of the main limitations of using the free tier of Backblaze B2 is that files are stored as private by default, meaning users can't simply click a link and download their evaluation report or graph. At first I thought this might be a deal breaker, but I discovered that Backblaze B2 supports generating expiring signed URLs using the S3 API via Python and the Boto3 library. Here's what happens. After the pitch graph and PDF report are generated in the Python script, both files are uploaded to B2 using the upload file method from Boto3. Then I generate 2 signed URLs that expire in 1 hour. These URLs allow students to download their report securely, even though the files are private on the back end. This gives me the best of both worlds, secure file storage and temporary access for users without needing login credentials. Now let's talk about another big challenge, Zapier timeouts, because the Python script handles multiple steps, downloading files, extracting pitch, generating graphs, calling AI APIs, and uploading results. It can take over a minute to finish. Zapier has a 30-second timeout for webhook responses, which means if I waited for the entire process to complete before replying to Zapier, the workflow would crash. The solution was to split the automation into 2 workflows. Workflow 1 handles the student's initial file submission, triggers the GitHub-based Python script, and immediately acknowledges the submission. Workflow 2 is triggered once the analysis is complete. The Python script sends a post request back to a second Zapier webhook, which then emails the student with their PDF report and pitch graph using the expiring URLs. This structure avoids timeouts and keeps the system responsive, especially helpful for students on mobile devices or slow networks. So now that everything is working, I can take a step back and appreciate the complexity and elegance of the system I've built. This project brought together a full stack of tools, and each one played a vital role. n8n handles user registration and subscription validation through WooCommerce. Zapier manages most of the automation, especially form triggers, file handling, and email delivery. Google Forms and Google Sheets make it easy for both professors and students to interact with the system without needing accounts or logins. Deepgram powers the transcription engine for comparing student and professor audio recordings. ChatGPT provides detailed feedback on lyrical content, pacing, and expression. Python on GitHub runs the pitch analysis and creates a visual performance graph. Backblaze B2 stores the generated files and delivers them securely via expiring URLs. I learned a ton while building this, and I encountered more than a few roadblocks. But I also saw how flexible and powerful today's no-code and AI tools really are, especially when you combine them thoughtfully. If you're interested in building systems like this, I've created 2 hands-on courses to help you. One that shows you how to integrate Zapier with Podia to sell and automate your own services, and another that explains how to use n8n with WordPress and WooCommerce to create a custom backend for subscription-based tools and agents like this one. You'll find both course links in the video description below. Thanks for watching. If you found this breakdown helpful, please like the video, subscribe to the channel, and leave a comment if you're working on a similar project. I'd love to hear how you're using AI and automation in your work. See you in the next video.